Okay, so now we're going to start with another proof. So here we have the figure shown in number 3. And what we're asked to prove is that RW is congruent to TQ. And what we're given is that RT, and this marking is parallel to WQ. And we're given that angle R is congruent to angle Q. So once again, I start to think if I can prove that these two triangles are congruent, then I can prove that RW is congruent to TQ using CPCTC. All right, so let's start out with what's given. So in our flow proof, we're going to say that RT is parallel to WQ. How do we know that? Because it's given to us. And from that fact that we know that these two lines are parallel, I think that's going to lead us to where we need to go with proving the triangles are congruent. Because if these two lines are parallel and TW represents a transversal, then these two angles are congruent. So from here, I'm going to say that angle RTW is congruent with angle QWT. And the reason I know that is because alternate interior angles of parallel lines are congruent. All right, so now I can see where I've got an angle and an angle. And let me get that other angle in my proof here. So I'm going to say angle R is congruent to angle Q. Why? Because that's given also. So as I was saying, I have an angle and an angle. And if I had a side, either the included side here or this side in the middle, I would be able to prove that these two triangles are congruent. So I'm going to go on to say that TW is congruent to TW. Why? It's shared between the two triangles. So I'm going to use my reflexive property here. So now I have that third side. So I've got an angle and an angle and a side. From my diagram, angle, angle, and side. All right? So these three statements converge for me to be able to say that triangle RTW is congruent with triangle QWT. And why? Because of angle, angle, side. Now that I've proven that both of these triangles are congruent, I should be able to prove, or I can prove, that RW and TQ are congruent. So I'm going to go on to say that RW is congruent to TQ. And why? Because of corresponding parts of congruent triangles are congruent, or CPCTC. All right, let's go on now to our fourth triangle, or fourth proof, again using triangle congruency. So once again, we're going to look at what's given to us. So what's given to us is that side AB is congruent to side BC. And we're given that angle A is congruent to angle C. And what we're asked to prove is that angle AEB, this angle here, formed right there, is congruent to angle CDB, this angle right here. So once again, I see that if I could prove that this triangle right here is congruent to this triangle right here, and notice that they're overlapping, but that's okay, then I can use CPCTC to prove that my two angles are congruent. All right, so I kind of have a direction. And what I start to notice is that if these two sides are congruent and these angles are congruent, then if I had another angle, I could prove using angle, side angle, that these two triangles are congruent. And what's significant is that this angle B is shared between triangle here, CBD, and triangle ABE. So the angles must be congruent using the reflexive property. All right, so let's get started. Once again, we're going to start with what's given. So what's given to us is that AB is congruent to BC. Why? That's given. And then we also know that angle A is congruent to angle C. Once again, given. And I also know that angle B has to be congruent to angle B. And how do I know that? Or what supports that? The reflexive property. All right, so I've got two angles and I've got a side, and all of that will lead me to be able to say the triangle ABE is congruent to triangle CBD. And why? Because of angle, side, angle. So I've demonstrated that the two triangles are congruent. So now I can move on to say that angle AEB must be congruent to angle CBD using good old CPCTC. All right, let's do one final proof, the last one, on our note sheet. And this proof, we're going to start the same as we do all of them. You all should be seeing the pattern. We're going to figure out where we're going. We're going to look for two triangles that we can prove are congruent. And then from there, we're going to use CPCTC to make our final step. So let's look at the problem. We actually have pretty good room on this paper at the bottom to make this proof. So first, let's start out with what's given to us. So we've got QP is perpendicular to PD, and ST is perpendicular to PT. And then it says QP and ST are congruent. And it says that angle Q is congruent to angle S. All right. So, and I can see that if I can prove that this triangle is congruent to this triangle, then I can start to prove some other parts of the triangle are congruent using CPCTC and get to this point that M is the midpoint. Okay, now that I've given you an approach for this proof, I'd like for you guys to pause the video and work this problem on your own, and then return to the video and look at the flow proof that I've developed and check your answers. This is the most difficult proof on this page. So if you're able to get this one right or close, you're probably in good shape on using these types of proofs that include CPCTC. So here's my answer, my flow proof. So let's check your work up against this. And sort of the order necessarily, or how the proof comes, is not as important as making sure your steps are aligned. By that I mean the fact that I laid it out on separate sides of the paper and kind of came from this side to this side isn't as important as making sure you have sort of the steps aligned. So check your answers, and we'll discuss this more tomorrow. Have a good evening. Remember to get your parent's signature at the bottom of your page. Good night.